Welcome everyone to the January 30th OMR Architecture Meeting. Today we have one topic, and it's an update from Mark on his recent progress with JitBuilder 2. So I'll turn it over to Mark and you can take us through it. Go ahead, Mark.
All right, thanks, Daryl. Wait a sec. It was a challenge to get the right thing shared. There we go.
Yeah.
You can see the window?
Yes.
All good? All right. Okay, so welcome to the 2025 OMR Architecture Meeting, I guess, everyone. The topic for today is JitBuilder 2.0, which I've renamed as JB2, just to simplify things and so I don't have to type as many characters all the time. I'm going to give a talk today that talks about some of, I think the last time I talked about this might have been August-ish timeframe. And while I haven't been able to work on it like constantly since then, I have done a bunch of things. And the work that I've been doing most recently is around trying to prepare it for contribution to OMR. So I want to get it out of my private fork and into OMR proper. So I'll talk today about the process that I've been going through and kind of where I am and what the next steps are. So just as a quick reminder for everyone, this is a slide I put up at the beginning of basically every JB2 presentation that I've done. Goals and motivation for the JB2 compiler. So it originates from, it's an evolution of the JitBuilder API that exists in OMR. And one of the, I guess there are sort of three main paths of sort of things that I was trying to improve with JB2. The first is around improving usability and making sure that people didn't have to maintain this kind of dual mental model between what JitBuilder provides and what the OMR compiler is doing. JitBuilder being just kind of a pass-through API, it forces you to program a certain way, but then debug things very differently because the OMR compiler doesn't know anything about JitBuilder. And so that can be kind of difficult for users, especially if they're not compiler experts. Along the same kinds of lines, logging and debugging and analysis with JitBuilder concepts would be like a lot nicer for people to be able to work directly with JitBuilder concepts if they're writing JitBuilder code. And also, I was hoping to get a chance to sort of re-architect some of the core features of our compiler technology in ways that might be easier to use or that might fit better with the JitBuilder concepts. I was also trying to make it a more extensible kind of framework. So in the course of building JitBuilder and people using JitBuilder, everybody always came along with their own special brand of new cool ideas that people wish JitBuilder could do. And some of them were able to be incorporated into JitBuilder, and others were just kind of left on the side because they didn't really fit either with JitBuilder or as a commonly useful kind of thing. So I was trying to make things more extensible and make it easier for people to add their own new types and new operations, and to be able to operate on JitBuilder more as an IR, an intermediate representation, so they could actually do analysis or optimizations even, or transformations on the code before it passes to what I call code generation, which is really just trying to convert the IR into something that can actually execute. And finally, kind of expanding on that earlier point, an easier experimentation path for new compiler concepts. So it's a little bit more freedom because it's divorced entirely from the OMR compiler component. It's a way to try new things and do things differently. Possibly enabling a wild and crazy path from moving from the compiler IR to something else like JB2, or something that JB2 evolves into, or a part of JB2. And just make it easier for those things to happen in parallel with the OMR compiler, and also possibly leverage things that are happening in the OMR compiler together. So JB2 is really a framework for building compilers that allows most of the core capabilities to be extended dynamically, and by this kind of pluggable notion that you can load a shared library that has an extension inside that shared library, and that allows you to use the code within that shared library. It just gets kind of basically fused into the existing compiler dynamically. So I'm not going to go through, I know it's been a long time since I've talked about JB2, so this will be a little bit of an abstract talk. I didn't want to go again through the examples of what JB2 looks like. There are earlier talks that I've done where you can look at that sort of thing. I haven't changed a lot of the sort of core what JB2 looks like. So if you remember what it looks like, then that's probably a reasonable mental model for you. If you don't know what it's like, you could go and look up one of the recordings of one of the earlier JB2 talks that I've done. I have definitely made lots of progress on trying to get JB2 ready to be integrated into OMR. But of course, there's still lots to do. It's always the case. I consider myself the primary limiting factor here. It's not that I expect other people to start working on JP2 as soon as I contributed, but certainly having it exist only in my private fork of OMR means it's extremely unlikely that anyone else is ever going to help me with anything. So I've been trying to look hard at how to integrate it into the project. It's currently sitting at about 31,000 lines of code. A bunch of that is tests, so I don't think it's all compiler, but there are a few extensions that I've defined as part of creating JB2 and to make sure that the extensibility mechanisms that I wanted JB2 to have are actually used and exercised and tested, and that they kind of work. There's a core extension which just has some very basic things and kind of it actually exists within the main compiler code base. It's not actually represented as a separate shared library itself. The other extensions are things that get loaded as I mentioned before, as shared libraries. So there's func, which just kind of provides the basic function support for generating functions. As an alternative, you could imagine other compilers that don't generate functions. They generate basic blocks or they generate traces or whatnot, where different kinds of things would be useful for generating code for those things. But func is, it provides the basic notion of a callable piece of code that has its own stack frame with access to load and store locals and parameters and be able to return values and be called. Base is an extension that has most of the original JitBuilder API in it, not all of it yet, but a bunch of it, and most of the most useful bits, including the ability to create struct types and pointer types and to be able to do for loops and if then statements and that sort of stuff. And then VM, which is one of the other parts of the JitBuilder API that got used quite a bit of the people who are actually using JitBuilder. I've also ported that across as an extension into JB2, so people can use that. And then the next two extensions are relatively newer ones, which are kind of pushing on the code generation concept and being able to take JB2 IR and plug them and be able to generate other representations, so ways to get to native code. So JB it used to be the case that JB2 would always just generate code by making JitBuilder calls at the end. While that's great, it does mean that it ties JB2 together with JitBuilder, which is tied together with the OMR compiler. And so these code generator schemes kind of started pushing on the extensibility mechanisms and making it easier to kind of disconnect the requirements for, what are you generating code to from JB2 itself. So JBGen is an extension that is, like I just said, it uses JitBuilder calls to generate native code. And it has some tests for that via the base extension. And then OMR Gen is one that I've written more recently, which directly generates OMR compiler IR, and actually includes quite comprehensive testing for everything that can be generated by this OMR Gen code generator extension is actually tested via unit test to make sure that it properly generates the code. So I took a much more sort of strenuous view of how to do the OMR Gen because it was a relatively newer path that I was trying to build. What else did I want to talk about here? It's not on the slide. I kind of forgot. I didn't have a place to put this, so I didn't really put it on a slide. But one of the other sort of major features that I implemented more recently was to take all of the IR concepts of JB2 and have the IR be held by an actual IR object. So everything within the IR for the thing that you're compiling is held by an object called an IR object. And that has some nice features in that you can guarantee that the allocator that's used to allocate all of the IR is the same as that IR object. Basically, the IR object is the thing that holds onto the allocator that gets used by all of the pieces of stuff that's in the IR. You can ask the IR object to clone itself, and it will create a completely independent copy using even potentially a different memory allocator that will make a complete copy of what the IR is, or what some subs. You can even use it to create copies of subsets of the IR, etc. So those kinds of things are some of the facilities that I've been building into JB2. Before I started my main focus on how do I contribute this to OMR. So in terms of kind of what's there, I would say JB2 is well into its proof of concept stage. As I said, it's about 31,000 lines of code, 24,000, is kind of implementation plus all the extensions, and then 7,000 lines of tests, 7 lines of code for tests. That doesn't mean 7,000 tests, but but it is probably on the order of a couple thousand tests that are done by those 7K lines. The core bits of JB2 are currently at just over 10,000 lines of code, and then the various extensions are between 1 and about 1,000 lines of code to do all of these things. It doesn't yet cover all of the original JitBuilder APIs, but it covers most of them. And I kind of prioritized things here. So at one point I was on a path to try and get JB2 to be a superset, or at least equal to what JitBuilder was. But I kind of prioritized that effort based on an internal stakeholder's current use of the JitBuilder API, and trying to see if I could get the JB2 code base to be at least someone able to support that internal stakeholder. And I kind of stopped that effort once I got to sort of the complete coverage. More recently, I've been focused on this integration step and figuring out how to bring this into OMR. I started at about 160 commits, many of which were just, MISC fixes, some fixes for this, some fixes for that. And I've kind of collapsed that down to what's currently at about 28. I've contributed some of the commits to the project already, although they're nothing that's actually contains JB2. But making some progress through getting some of this code into that was formed as part of doing JB2 into OMR proper. And lately, this has been my only focus, has been trying to figure out how to get this thing integrated. So, if you remember anything about how JB2 used to be organized, and I'd be surprised if anybody else did, but if you have, this is a slight change that I've made here. Otherwise, just listen to this and have an idea of at least how JB2 is organized in my current fork of OMR. So I've promoted JB2 to be a top level component. So just like JitBuilder is a separate component, JB2 is a top level component now, and I've given it its own namespace. It used to live in OMR JitBuilder, just like JitBuilder did, because it was version 2.0 of JitBuilder. But I've decided to call it JB2, and that kind of helps me evolve it independently of the JitBuilder stuff. I don't have to worry about name collisions between JitBuilder and JB2, for example, anymore. The extensions all get their own sub namespace. So the JB Gen or base extensions, for example, are OMR JB2, JB Gen, etc. And the other big change from what I would have talked about previously is that JB2 is no longer an OMR compiler extension. It is a standalone component, so you can build the JB2 stuff without having to build the compiler component if you don't want to. The dependence for JB2 on other parts of OMR, i.e. the JitBuilder library or the OMR compiler, have been isolated to within specific extensions. So JBGen isolates the JitBuilder dependence. So if you build the JBGen extension, you do have to have you have to be also building the JitBuilder library, but you don't have to build you don't have to specify anything else. If you're building the OMR Gen extension, then basically builds its own OMR compiler underneath the OMR gen as part of the OMR gen extension. What that means is that if you don't build OMR gen, maybe you only use JB gen, then it will just it will use an existing JitBuilder library that's been produced as part of the OMR build process. Or if you do OMR gen, you can use the OMR compiler and you don't need to build JitBuilder at all. And if you were to implement your own code generator and didn't need, or you had a use for JB2 that wasn't necessarily requiring code generation because you were using it for, say, some type of analysis only, then you would not need to build JitBuilder or the OMR compiler components. So that's sort of a nicer feature, I think. To get to this point, I've been doing a bunch of work to try and move code from the various compiler extensions that we have, i.e. JitBuilder and compiler test, and previously JB2, so that more stuff is kind of provided by default in the OMR compiler component itself. So I'm going to talk a little bit about some of the things that I've been doing there. In the process of moving most of them. Oh yeah. So this bottom point, these bottom two bullets here. So as of the writing of this slide, which is actually, it's incorrect right now, but I am in the process of moving most of the OMR gen extension, like the actual code that implements the OMR gen extension, into the OMR compiler. So the files that build the OMR extension, I'm moving into the compiler component under a directory called JB2CG for code generator. But those won't be built by default if you want to build an OMR compiler. You have to include them in your compiler extension if you want. So OMR gen is then a compiler itself, which then can specify that those files should be included in the build. It makes it relatively easy to do an extension without having to do very much work. And it also makes the files available as part of the compiler component for anybody who consumes the compiler component. For example, OpenJ9 could decide that it wanted to include those JB2 gen or CG, files very easily by incorporating them into their CMake files, and then we could use JB2 from within OpenJ9 in a relatively straightforward way. Well, I haven't tested that yet. All right. So like I said, so a lot of that process ended up making it actually got me most of the way towards making the OMR compiler component sort of a standalone library by default. So if you're not doing anything complicated with the OMR compiler, you can almost get by with everything that's in the compiler component itself. So in principle, at some point, if we were to fix a couple of things, we could probably just move the OMR compiler to the same model as the other OMR components and have it just generate an OMR compiler.a or whatever, and have that linked into whatever it is that whatever runtime you're using. You wouldn't necessarily have to create extensions and various things, which is what the model in the OMR upstream forces on you. There's a whole bunch of stuff that you need to basically include some basic pieces of in order to create a compiler in the first place. But really, those are just default implementations. And because of the extensibility mechanisms that they rely upon, it's not difficult for a compiler extension to override those default kinds of things. So on this slide, I've listed some of the things that I've done. I basically just went through a list of the commits that I've got in my JB2 branch in my private fork, which contains all of these kinds of changes. So, for example, there's no TR front end defined by the OMR compiler component itself. You have to define that. So we can very easily add just a default one, and then just because of the way OMR's the compiler extensibility works, if a new compiler defines its own front end.hpp, it won't use the one that's in the OMR compiler, and so you're free to just kind of continue on. It just kind of works. I don't know why we didn't do this in the first place. This one seems like a pretty obvious one. Similarly, there's some kind of default stuff that we could put in for object model and stack atlas pod and those kinds, and default code cache segment allocation that they're sort of reasonable defaults for people who want to build a compiler that doesn't necessarily leverage a lot of other stuff from OMR. And it can vary, with very straightforward implementations of these things, you can just bring them in. Slightly more advanced was to enhance what the default method and resolved method definitions look like in the OMR compiler. This one's a more complicated change, and I confess I don't have all the details in my head right now, so I'm not, because I didn't refresh myself on the commit before I came here, but I believe I also, as part of this, made an effort to try and unify the tr::: resolved method and tr_ resolved method sort of dichotomy between OMR and within OMR. So we have both of those things, but I try to kind of make them in the same inheritance chain. So and I think that helped with some stuff. But I'd have to refresh myself on what's actually in the commit. Another sort of interesting change I did was, so the way the OMR optimizer is structured right now is if you want, so the default optimizer kind of includes all of the optimizations that OMR includes as its in optimizer, OMR optimizer CPP. And that the way that it gets initialized basically forces the compiler to allocate an object of all of the different kinds of optimizations. And so if you write a compiler that doesn't necessarily want to run all of the optimizations, you basically get a full-sized optimizer, but you don't use very much of it. So in JitBuilder, one of the things that I overrode in JitBuilder was I specified my own JB optimizer, and that optimizer actually performs the initialization of the optimization structures rather than the base class, the OMR optimizer one. And only initializes a few of the optimizations that are actually used in JitBuilder, and that managed to reduce my library size by a couple of megabytes, I think, on Linux x86. So that was a significant benefit because I didn't really need all of the full power of the optimizations that were in OMR for the JitBuilder optimizer that I was using. But it does mean that like the mechanism to do this, because you kind of need to either include or you need to initialize all of the optimizations at some point, and it's tricky to coordinate that between two different projects. So basically the way it was done is OMR optimizer does what it does unless there's a pound_if_def macro that's been defined. And if there's a pound_if that macro is defined, then it basically doesn't initialize anything, and you rely entirely on the compiler extension to initialize the optimization structure, which is pretty awkward because it forces all of the work into the compiler extension. So rather than do that, I kind of created these two example optimizers inside OMR full optimizer, which is the equivalent of OMR optimizer right now. It includes all of the optimizations there. And OMR small optimizer, which is essentially the same thing that JitBuilder had in its own definition. And then with a little bit of pound_if_def macro and stuff and CMake support, either a compiler extension can use the full optimizer or it can use the small optimizer. It builds one or the other basically, and it gets kind of swizzled in optimizer.hpp when it figures out when it's deciding what to do, what to make tr optimizer. It basically just either extends full optimizer or small optimizer, and you get whichever one you build. I also read another sort of larger scale change that I made was to rewire the trill and compiler unit tests, which weren't actually set up to depend on JitBuilder, but they actually do expect JitBuilder to be there and to be built, I believe. So I just kind of changed things so that it actually depends on JitBuilder rather than depending on the OMR compiler. And I can't remember specifically, again, I'd have to go back and review the details there, but I think when I changed this, I actually reduced the number of compiler builds that happen as part of the OMR build. So this one might actually save us some time, assuming that I'm right about that. What else? There's a bunch of code that's kind of common between all the compiler extensions that we have, like JitBuilder, compiler test, and JB2 have some runtime and codegen support for the various platforms that kind of doesn't get implemented by the OMR compiler. So I tried shifting some of that back into the OMR compiler. Again, as kind of default pieces that I guess wouldn't necessarily need to be used by other compiler extensions. Like OpenJ9, for example, probably doesn't use those default ones because they're not there. Um, let's see. I also, another sort of required thing that you have to do if you implement a compiler extension is to create your own IL generator method details, because the default one that's in the OMR compiler isn't very useful. So I sunk a bunch of stuff from the compiler extensions we had into the base one, and that kind of makes it more useful as a unified thing. I also the one that the extensions that were based on JitBuilder basically use some JitBuilder concepts when they're initializing an IL generator method details that it doesn't really need to do that. So um, I simplified some of the code, some of the consuming code in our compiler extension so that it didn't necessarily use the JitBuilder concepts to provide the details of the generation. Yeah. And also the last thing is that the OMR compiler component doesn't really have any compiler lifecycle stuff like initializing a JIT, shutting down a JIT, doing a, calling it to compile a method. So I took some of the basic stuff that's in JitBuilder and kind of provided that as simplegit.cpp, which again, I don't believe I have that being built by default in the OMR compiler component, but if an extension adds that to their compiler definition, then it will just build, but the code actually comes from the OMR compiler component. And so with all of that, I know that was a long list of awful things sounding. With these changes, the OMR compiler gets closer to being able to kind of stand on its own and be able to just get used by things downstream. So, for the most part, you just need to specify your own CMake lists txt and not have to actually make copies of all these other files that, for the most part, at least the compiler extensions in OMR, they're mostly just copies of one another that you need because the OMR compiler is kind of incomplete in all of the ways that I just described. So by adding sort of the default implementation into the OMR compiler itself, you no longer have to sort of duplicate and replicate that stuff. Simplifies integration for new compilers. I guess there may be some impact to some consumers. So when some of these commits start to land, I'll probably be reaching out to the people that I know about who are consuming OMR to see if this is going to have any impact on them. I've tried to design these so that they won't impact existing stakeholders, but obviously that's a want and wish, not necessarily a will. So it'll be good to get some feedback on that when we get through that. All right. I'm almost at the end here. So basically, what are the next steps? What's still to happen at this point? So like I said, I'm in the process of kind of migrating the codes that implement the OMR Gen and JB Gen extensions into the OMR compiler and into the JitBuilder components so that the code actually resides there, so that if people leverage the OMR compiler or if they leverage JitBuilder, they'll also have the ability to kind of leverage JB2 relatively easily without having to grab a bunch of code from another place. I'm also right now, if people have been really paying attention to OMR, you'll see that I've actually contributed a bunch of code to OMR in the last couple of weeks. That there's some things that I found along the way. I didn't think that they were essential, so I didn't really focus on contributing them as I went, but now it makes sense to actually put some of the stuff in there. So there's also a big sequence of changes to JitBuilder, sort of augmentations and a little bit of some changes to JitBuilder. So if we have JitBuilder consumers out there, you'll want to watch this series of commits that happen, and I'll be identifying that as a JB colon in the in the pull request when it comes out. Again, anyone that I know of who's actively developing a JitBuilder based compiler, I'll reach out to them to let them know that those changes are coming, but they're not really. There's only one of them I can think of that might be disruptive, and it's one that changes one of the char star parameters to a const char star parameter, which might impact some people. But for the most part, it's just kind of adding little tests to make sure, like, for example, one of the changes is ensuring that you can do if CMP type operations on AArch64 with narrow width integer items, which are not implemented by the AArch64 cogens. So it introduces some code in there to basically widen anything that's of a narrow data width if you're on the AR64 platform. So they just work, or appear to just work from the JitBuilder standpoint. After I get through that sequence of JitBuilder commits, then I'll start going through that list of commits that I just talked about on the previous page, right? The ones that are trying to sync more of the code into the OMR compiler itself from our compiler extensions. That'll simplify some of our compiler extensions that we've got, as well as make OMR compiler more standalone. And then that will get me to finally to the initial commit of JB2, which is kind of all of the extensions that I talked about previously, plus the tests, and that's about 27,000 lines of code. So that's one big commit. But when I had 160 commits, there were probably 100-ish of those that were for this initial commit, and I didn't think it would be worthwhile for anyone to go through all of that history, especially since some of it was pretty stupid. And a lot of them were actually full scale, like, in one commit, I would change every file in the entire code base. It didn't make sense to present all of that history to anyone for the project. So I collapsed it already into one commit that basically just introduces everything in, along with those sort of core components, core extensions that I talked about previously. It will include the tests. The tests will run as part of the default C test. If you just specify when you do your CMake build, if you add OMR underscore JB2 equals 1 or on, then it will automatically build JB2. It will automatically build the default set of components or extensions that it knows about, that it knows work. And then it also includes a bunch of tests that test various things that's part of the JB2 infrastructure. I would be the first to admit this is not a comprehensive set of tests, but some of them are better than nothing, and some of them are better than anything else I think we have. Like the OMR Gen ones, I think are actually quite good, and quite comprehensive in terms of like testing everything that's in the OMR Gen extension and supported by the OMR Gen extension. Right. So the JB Gen extension, if you don't specify it, or if you specify that you want the JB Gen extension, it will build the JitBuilder. I think by default, it probably won't build the JB Gen extension, which means it won't force it to build JitBuilder. Although I know in our testing, we'll probably build JitBuilder, and therefore we'll build the JB Gen extension and then run the JB Gen tests, or the base tests actually. Um, uh, yeah. There are some things that I want to do before I contribute this, though, one of which is cleaning up the internal documentation. So I have tried to document a few things as I went along, but it's stale like all documentation. So I need to go through and sort of clean that up. And there's probably a few other things of that sort of cleanup, kind of, not having stale comments in a couple of places that I'll go through and clear up before I do the initial contribution. I'm aiming at this point to have that JB2 pull request ready to review by the end of first quarter, so end of March. Hopefully I'll get there earlier, but it all kind of depends on how busy I am outside of doing this stuff, which is all just hobby stuff for me at this point. So, I get through it when I get through it. And I think that's it. That's everything I was going to talk about today. So I apologize, not very much code or technical stuff today, but hopefully it's interesting and people have a better idea of what to expect going forward for the next couple of months, at least from M's Toodle. Are there any questions, comments? Outright rejection? Hell no, we don't want JB2.
Gonna wait for JB3.
I can fix that. That's an easy change.
No, this sounds good. I mean, it's
I've been
great to
working on
see
it
that
long
it's
enough. It
getting.
should probably be JB4.
No, it's good that it's finally, you have a very near date that you're targeting for delivery, so it's good. Well, I mean, not delivery. You're going to open the PR, so then we'll have to get through it.
Yeah.
Any
Yeah, I
questions
don't
for
know what
Mark?
to, I don't know what, I don't know what to recommend. I mean, 27,000 lines of code is a lot to review, so it's not like um, I don't know what I expect from a reviewer to look at 27,000 lines of code, but I mean, I guess in principle, I could do a first PR that's like 10,000 lines, which would be the sort of core componentry, but you wouldn't be able to do very much with it. And that does include some tests, but they're very, very basic tests and not very particularly useful. So and it's hard to kind of imagine how to use it from just the core implementation because it basically like creates a bunch of extensibility mechanisms and then doesn't use them at all. So it's hard to appreciate what they're for without seeing the other things.
If most of the 27,000, as you said, are tests, then that isn't so
Well,
bad.
7,000 of them are. I wouldn't say most.
Oh, I thought you said most at the beginning. Oh, okay.
No, I think it's about 20, 21, 20 to 21, a little over 20, I guess. 20,000 lines of code and then about 7,000 lines of tests.
So much.
Yes. We can argue over the adjective, yeah.
All right, very good.
Right. I know I didn't provide very much detail for people to chew on there, so that's I don't expect a lot of feedback here, but um hopefully hopefully it won't be something that seems completely useless once it actually gets contributed. And I think some of the commits that I'm putting in now are actually more broadly useful too. So hopefully at least that gets done.
All right, thanks, Mark, for the update.
Yep.
All right, well, that was the only topic that we had for this week. So thank you again, Mark, and we will convene again in 2 weeks. Thanks, everyone. Bye.
Thank you. Bye.